In this lesson, we're going to talk about measures of position. This is an extension of the concept of the median being the center of the data. We might also want to know more than just where is the center of the data, but where is the first quarter of the data? Where is the third quarter of the data? So to do this, we call these things quartiles. Quartiles are defined to be the value greater than 25% of the data, 50% of the data, which is actually the median, and 75% of the data. In order to calculate these quartiles, we'll first take the data and split it in half, finding the median in the process. Then the first quartile is the median of the first half, and the third quartile is the median of the second half. Now, occasionally what could happen when we're doing this is your data might have an odd number of values. How do you split the data in half when it has an odd number of values? The idea is we will actually keep the median in both halves, and that will make it work. Let's do an example. Find the three quartiles for this data set. Just like in the last lesson, let's start out by putting the data in order. I'll go a little faster this time. Looks like 2, 3, 5, 7, 8, 9, 10, 12, 15. I did that kind of fast, so I just am double counting right now. Yes, I have 9 data points here and 9 data points in the original data set. The first step in finding the three quartiles is find the second quartile. The second quartile is actually, like I said, the same thing as the median. To find the median, just like last time, you'll do a left, right, left, right. Feel free to go faster if you want, but I get that it's 8. Now we split the data into two halves. Like I told you, if there's an odd number of data values, you don't have two even halves. What you do is take the first half to include the median, and the second half to also include the median. This is the strategy that will actually find the quartiles that you desire. Now, for quartile 1, let me copy down the 2, 3, 5, 7, 8. Again, this is the first half of the data. For quartile 3, I'll copy down 8, 9, 10, 12, 15. And keep in mind that I did use the median twice. Now, the first quartile is the median of this data, which is 5. The third quartile is the median of this data, which is 10. And those are your three quartiles. Again, start by finding the median, break the data into halves using the median twice if need be, and find the median of those two pieces to give you your three quartiles. Let's do another example. This data is again not in order. It's a little bit longer, so I'm going to be careful. I see a 10, 10, 12, 14, 14, 15, 16, 17, 17, 17, 18, 19. Now let's calculate the median. I'll do like 3 on the left and 3 on the right, maybe 2 more. And it looks like I have 2 data points for the median. The median is my second quartile, and again, anytime I'm trying to do a median, I will take the 15 and the 16, the middle two, and average them together to get my actual value of my median. Now let's split the data in half. This time, since there were 2 even pieces, I can use these two halves separately. Here's the setup for my remaining 2 quartiles. I've taken the 2 halves and split them up to do the quartile 1 for the first half and quartile 3 for the second half. Again, we just now calculate the median by crossing off things on the left and right. Looks like I have an even number again, so I'm going to do 12 plus 14 divided by 2. It's just the number in the middle, which is 13. And then for quartile 3, I can cross these values off, but I don't see any reason to average them together. They're the same. It's 17. Now let's talk about percentiles. Sometimes we want to get more information than just breaking the data into 4 pieces. If there's a lot of data, it might make sense to break it down into 100 pieces. You've probably seen a percentile before when you've taken a standardized test. Thousands, maybe millions of people take those standardized tests, and they will tell you what percentile you lie at. The percentile simply is saying, if you are in that particular percentile, then you are greater than that percent of people with whatever number you were given. As the example here, the 63rd percentile would mean that you had scored higher than 63% of the people who took the test as well. There's two formulas that we use for these, and both of these formulas are useful. One of the most common mistakes that I see students make while doing these percentiles is they don't pay careful enough attention to what the variables represent. This is actually critical information to get percentiles right. P stands for percentile, as you would expect. N stands for the number of data items. B is the variable that I've seen more students have to ask questions about because it is a little bit tricky. They get confused. B stands for the number of data items that are below, numerically below the pth percentile. So you actually have to count off how many items are lower than the value that you're looking at right now. This is best illustrated by examples. Before we get to those examples, let's take a look at just a few notes. As I mentioned, B is going to be the number of items below a value in the list. So with that said, you're going to have the next item chosen to represent that percentile. So if you had 5 items below, then you would pick the 6th item. Also, when solving for B, sometimes B will come out as a decimal. If you get a decimal, in order for this to work, you must round down. When I said B equals 5 for my example a second ago, let's say I calculated and got 5.9. The 6th item is still higher than 5.9 of the data. So I would round the 5.9 down to 5 and choose the 6th value. Again, we'll look at that in an example in a moment. If we get an integer value for B, we'll just use that number as it is and not round it. When we're solving for P, plugging in B for a value and solving for P, then we'll round up to the nearest integer for P. The percentile always has to be rounded up, whereas the B always has to be rounded down. Now let's do the example. Whenever we're doing percentiles, normally percentiles are calculated with a tremendous amount of data. However, this would not be practical for you to try to do with just a lot of data, so I'm going to do it with only 25 values. By the way, that's your N. So N equals 25. N is the number of data points. I want to know the value of the 10th percentile. B equals N times P over 100. And we're going to solve for B and see what we get out of this. N is 25. P is 10, and we have over 100. I get 2.5 for my B. Now remember what I told you about B. B will always be rounded down to the nearest whole number. So I'm going to round this number down to 2. This represents the number of values below my answer. So I want to pick the number that has 2 values numerically below it. Now if you look at the data, I didn't write it out horizontally, it's just kind of written in numerical order left to right, top to bottom like we standard read. So all I'm looking for is numerically what number has 2 values below it. Here's the way that I do it. 1, 2, answer. Again, count off 1 value below, 2 values below. This is the number that has those 2 values below. With that said, my answer is 17. 17 is the value that has 2 values below it. It's the value at the 10th percentile. Let's do another example. For the 40th percentile, we've got the same formula. N is still 25, and now I'm doing 40 for my percentile. If I calculate this, I get 10 this time. 10 is an exact number, and it's the number of values below my answer. Again, the number of values below it, numerically below it. So let's start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is the number that has 10 values below it. So my answer is then 20. Let's do one more example, and then we'll switch it around. This time, I get b equals 25 times 85 over 100. I get 21.25. Again, round down. So I'm going to have 21 values below my number. Again, just count it off. I'm going to go a little bit faster this time. 5, 10, 15, 20, 21 below. There's my number. So you're always going to count off the number that are below, and then the final one, the next number in the list, is your answer. So in this case, 31 is at the 85th percentile. Now let's flip it around. If I want to find the percentile, the formula is 100 over n times b. This time, I need to calculate b so that I can calculate p. Well, n is still 25, just like it was in the last 3 examples. And now I'm told that the score is 23. Here's the most common mistake. That is not the value of b. 23 lies right here. b is the number of items below the 23. So what you need to do is count how many items are below 23. 5, 10, 11, 12, 13. There are 13 values below the 23. Let me just write it down. b equals 13 values below 23 in the data. Now I can plug all of this in. p is then going to equal 100 divided by 25 times 13, and I get 52. This is what we call a percentile, and often percentiles are listed as ordinals. So to write this cleanly, I'm going to call it the 52nd percentile. It's just a good unit to put on these when you're doing them. Let's do another example. A score of 35 is at which percentile? Let's start out by calculating what is my b here. 35 is the largest number in the list. How many values does it have below it? You can count them. There are 24. Now let's use this information. Plugging into my formula, I have 100 over 25 times 24. I get 96. And again, let's write that as the 96th percentile, just to write it with a nice unit. Now this brings up an interesting point. You may know that the highest percentile you can achieve is the 99th percentile, but 35 was at the highest point in the data. This can happen sometimes if there's not enough data or there's a high concentration of maximum scores in the list. An interesting example that I've encountered of this is the percentile on the GRE for the math portion. Just the standard math portion of the GRE that all people going to graduate school will take. The highest score is actually not at the 99th percentile. That's because there's so many people who would find that portion easy because of their training in mathematics that they earn a perfect score. Because of this, that number is actually not the 99th percentile. Approximately 3 to 4% of the people who take the test will earn a maximum score because their mathematical sophistication is just so high. Let's do one more. With the 19, how many values are below 19? Well, the question is, which 19 do I look at? You will actually always look at the first one when something like this comes up. And from there, you can see that b equals 6 values below the first 19 in the data. Let's use this formula one more time. 100 divided by 25 times the 6 values that are below will take me to 24. So this is the 24th percentile. And again, this is related to the idea that there are multiple 6s, so I'm just going to grab the smallest one. That's saying all the 19s lie in the 24th percentile, because you really can't determine which 19 to look at other than this is the first 19 that starts it.